We are continuing now with this test review. I think we're ready to do some derivatives. So let's look at what we have going on. I think we're ready for problem 43. So they're saying find the derivative if y equals this. So let me write it down. And then we'll talk about so the equation is y equals x to the fifth minus 8x to the fourth plus 8 over x squared. And they want us to determine the first derivative or the derivative. All right. You have now learned and you understand all the different rules that you can use to determine derivatives. Power rule is probably the most common. Sometimes you have to use the product rule. Sometimes you have to use a quotient rule. Sometimes you have to use a chain rule. There's all these different rules that allow us to figure out derivatives. And like a lot of math, there are oftentimes more than one way to solve a problem. When I look at this equation, since it's a fraction, my first thought might be, oh, I will probably have to use the quotient rule to solve this problem. And you could use the quotient rule and it would work to solve this problem. But sometimes, occasionally in math, there's a different way to do things, and sometimes there's one way that's a lot easier than the other. And that's this case here. I could do the quotient rule, and it would be sort of messy, but I could get it. But there's an easier way. With this one, because I look at my denominator, I'm going to go ahead and take this one fraction and split it up into 3 different fractions. Hopefully you remember how to do this from algebra. So I'm going to say I can rewrite this as x to the fifth over x squared minus 8x to the fourth over x squared plus 8 over x squared. It's almost like we're doing the opposite of when you add or subtract fractions, right? 3 fractions, same denominator, you can make it 1 fraction. It's like I'm doing the reverse. I'm taking 1 fraction and splitting it up into 3 separate fractions. And the reason I do that is because if I cancel here, x to the fifth over x squared is x cubed minus 8x to the fourth over x squared is 8x squared. Now this one, because here's what I'm going to do. You know what I've done now? I've created a problem where I can simply determine the derivative by using the power rule. Power rule is a lot easier than the quotient rule. So I could have performed the quotient rule on this whole thing, or now I can simply go through and start using the power rule for each of these terms. And because of that, when I write this last one, to use the power rule, I need to go ahead and move the variable up into the top. So now, to take the derivative, pretty straightforward. 3x squared minus 16x. Now here the negative 2 comes negative 16, then x to the minus 3. And there is my derivative. Now, if you went ahead and did the quotient rule, you should have gotten the same answer. But I think this way is a lot simpler. So that's the idea there. Sometimes they want you to be smart and find a simpler and easier way to solve these problems. So I have 3x squared minus 16x minus 16 over x cubed. All right. .44, let me write this one down, then we'll talk about it, work through it. So y equals, in parentheses, 2x to the fourth minus x plus 1, and then negative x to the fifth plus 4. And once again, they want us to take the derivative. Let's look at this. Here's another case where there's probably two different ways to try and solve this problem. One way is, you know what, if you multiplied out these parentheses, you'd have like, I don't know, maybe like 6 terms or 5 terms. And then each one of those, you could use the power rule. Or you could try and use the product rule, where you take the first times derivative of the second derivative of the first. In this case, in my mind, it's not a clear-cut option of which is the easier way. I think just for fun, and I think what they're wanting you to do here is maybe go and multiply it out. They're wanting to show you that you can do that. So let's do that. We'll do a little algebra first. So once again, this 2x to the fourth, I'm going to multiply by both these terms in this parenthesis. I distribute it through that. So it's going to be 2, actually negative, because I got negative for a negative 2x to the ninth. Then 2x to the fourth times 4 plus 8x to the fourth. Now I distribute to minus x. Minus x times minus x to the fifth is plus x to the sixth. Minus x times 4 is minus 4x. And then distribute the 1. I'm just going to have minus x to the fifth plus 4. Now I have to see if I have any like terms, and I don't. All these variables are different. So at this point, I can simply go ahead and take the derivative. I'll probably try and do it in descending powers. So I'll mark these off to make sure I don't leave any out. So let's do this one first. Negative 2x to the ninth is negative 18x to the eighth. This one would be next, plus 6x to the fifth. Then I got this one, minus 5x to the fourth. Then this one, plus 32x cubed. Then minus 4. And then this is going to be 0. So there's my derivative. Just for fun, if I did the product rule, I won't finish this, but I'll just start it out. When I do the product rule, I always write the first times the derivative of the second. Derivative of the second parenthesis would be minus 5x to the fourth plus the second times the derivative of the first. The derivative of this first parenthesis would be 8x to the third minus 1. Now what you have to do here is now you have to multiply out all your parentheses. They combine like terms. Still a lot of algebra. So that's why I said in my mind, either way is a lot of algebra, sort of unavoidable. But if I finish this one, I should get the same answer, of course. I just wanted to sort of show you that in this case. This earlier problem, I think it's clear cut the way I did it. is a lot simpler and easier, less messy. This one, it's sort of a wash. I'm not sure which would be better. It's just a lot of algebra. You have to be careful. So let me plug this in and see, hopefully if I did it correctly. So I have negative 18 x to the 8th plus 6x to the 5th minus 5x to the 4th plus 32x cubed minus 4, and we cross our fingers, and that's good. Did it correctly. All right, 45. This one we have no choice, really. Definitely quotient rule all the way. So let me write it down, and then we'll apply the quotient rule and see what we get. Just so you know, whenever you take a derivative, usually the quotient rule are the ones that get the messiest. Lots of fractions, lots of crazy stuff going on. 3x squared minus 8 over 5x cubed plus 1. And we want to take the derivative. All right, quotient rule. Remember the little saying? Low d high minus high d low over the low squared, right? Low, so I copy down what's in the bottom. Low d high, derivative of what's up here, 6x, minus high, so I copy down what's in the top. D low, derivative of what's down here, over the low squared. Now, part of the problem is with these problems like this is you try and simplify it some, and you try and put it in the form that hopefully my math lab likes. But you have to be careful with the algebra because it's easy to make mistakes. So for instance, I need to go and multiply out these parentheses in the top and combine like terms. And then I'll probably stop there, and hopefully that'll like the answer. So the 6x distributed, 30 x to the 4th plus 6x. Now you notice this is subtract, so really everything over here is going to be minus. So 15x squared times 3x squared is 45x to the 4th, but it's a minus 45x to the 4th. 15x squared times negative 8, that's a negative number, but since I'm subtracting it, it's actually going to be positive. So 8 times 15 is, I think, 120. All of that, and I'm not going to mess with the denominator. So do I have any like terms? Yes, I do. I've got 30x to the 4th minus 45x to the 4th. That's minus 15x to the 4th. Then plus 120x squared plus 6x all over Now, here's where it gets sort of interesting because, for instance, in the top, I could factor out an x, but it's not really going to cancel or buy me anything. I'm pretty sure this thing doesn't really factor. I think I'm probably sort of done. At least I'm going to hope so. So I'm going to go back in and enter this as an answer and see if that's what my math lab was wanting. I don't know for sure. We're going to find out. So in this case, it's going to be a big fraction. So I need to use these tools down here. So at the top, I have negative 15x to the fourth plus 120x squared. Oops. Plus 6x. Then in the bottom, I actually need to put parentheses. 5x cubed plus 1 All right, I have no idea whether this is going to be correct or not. I think I did it correctly, but we'll see if my math. Okay, that's nice. All right, number 46. Once again, two different ways to figure out this derivative. Excuse me, in this case, I think definitely one way is easier. So of course, that's the one I'm going to choose. So f of x equals 7x plus 8 squared. And they want us to take the derivative. So that's just two different ways. You could actually multiply this out and then probably use the power rule. But you know what? We've got this thing called the chain rule, which makes this one pretty easy, right? Because the chain rule, in this case, you've got parentheses raised to an exponent. So what's the chain rule say? You sort of do outside then inside, right? Outside is 2. You simply copy down the stuff inside the parentheses and then you subtract 1 from the exponent. So there's a 1 here. Then you multiply by the derivative of what's inside, which is just 7. And we're pretty much done. That's why using the chain rule makes it pretty simple. Now there's a chance I could multiply out these parentheses. Let's just go ahead and do that. 70 plus 28, 108, 98, right? 70 plus 28, 98x. 80 plus 32. Let's see if my math lab likes that answer. 98x plus 112. My guess is if I would have taken either one, it would probably be okay with the parentheses. Hopefully it's smart enough that it is happy with both. But I just decided to multiply it out. So chain rule makes that one pretty easy. 47 is really two terms here. You got this big fraction plus x cubed. So I'm gonna, when I take the derivative, I'll do these sort of separately, right? I'll do this, take the derivative of this fraction here. Then the derivative of x cubed is pretty simple. So really most of the work, I'm gonna have to use the quotient rule for this. So this derivative of the fraction is going to be sort of messy. let's go ahead and write it down so I can do it. This is 47. So g of x equals 2x minus 7 over 7x plus 1 plus x cubed. And they want us to take the derivative. So like I said, it's really almost like taking two derivatives. Derivative of the fraction, derivative of this x cubed. X cubed obviously is very simple. This fraction, I'm going to have to use a quotient rule. Quotient rule almost always gets messy. So low d high, derivative of the top is 2, minus high d low, derivative of the bottom is just 7, over the low squared. So that is the derivative of this fraction. So then I take the derivative of x cubed using the power rule. Now what I probably need to do is multiply out these parentheses. So to simplify the top here, then I'm probably going to be done. 14x plus 2. Once again, be careful, I'm subtracting this whole thing. So 7 times 2x would be minus 14x. And then 7 times negative 7 is negative 49, but since it's negative, it's plus 49 over 7x plus 1 squared plus 3x squared. It's interesting is I combine like terms, 14x minus 14x, those actually sort of cancel out. I'm left with 2 plus 49, so 51 over 7x plus 1 squared plus 3x squared. Not a whole lot more I could do than that, so let's see how this looks. So let me put the fraction here. So it's 51 over 7x plus 1 squared plus 3x squared. All right. Let's maybe do a few more of these before we stop this video. F of x, 1 over 2x minus 7. This actually, normally, the farther you go, the harder the problems get. This one doesn't look that hard to me. Maybe I'll be fooled. F of x equals 1 over 2x minus 7. Although this presents, once again, an interesting dilemma of how we would like to solve it. Because I could use a quotient rule, and it wouldn't be that hard. But then just so you'll know, someone might say, I rewrite this and move this parenthesis to the top by making an exponent -1. And then what could I do now if I want to take the derivative? I could use the chain rule. Matter of fact, this problem is easy enough. Maybe I do it both ways just for fun. So if I do the chain rule of this, it would be -1 times 2x minus 7 to the -2. So when I simplify it, and just for fun, if I did the quotient rule, low D high, what's the derivative of 1? It's 0. Minus high, D low. Now I'm stopping because it looks like I may get it. Oh, I didn't do the chain rule correct. Chain rule, I did the outside, I forgot the inside. Because as I'm doing this, I'm saying these aren't going to be the same. I forgot to complete my chain rule. So finish out the quotient rule. This whole thing is 0. So minus 2 over 2x minus 7 squared. So obviously you get the same answer no matter which method you choose. So -2 over 2x minus 7 quantity squared. All right, let's take a break now because here we have another equation of the tangent line. We've done these before. Might just be a little messier because of the initial function. But we will start this again on the next